Children, let's see what is this one trying to say. Quite interesting, very interesting. In the adjoining figure, LMN is 90. LMN is 90 degree. LKN is also 90. MK perpendicular to LN. MK perpendicular to LN at point R. Prove that R is a midpoint of MK. Prove that R is a midpoint of MK and not LN, mind you, MK. The moment you all see perpendicular, everybody goes for what? Everybody goes for Pythagoras, searching out how we can work out. What I have a technique. Check this sum part by part. Forget this portion is there. Forget it. You don't have this portion. So what you have? You have is only right angle triangle LMN. Forget this portion is not there. So you have only right angle triangle LMN. This is 90. Now, do we have a perpendicular from that 90 onto the hypotenuse if I don't take this? So is MR perpendicular to LN? Yes. So if we have a right angle triangle and a perpendicular is drawn from right angle onto the hypotenuse, geometric mean corollary. Many must have gauged it. Whom should we call for? Geometric mean corollary. So let's start. In triangle LMN. What is the condition for geometric mean corollary? GMC in my language. What? You have to have a right angle, which we have, and from right angle perpendicular onto the hypotenuse. So in triangle LMN, measure angle LMN is 90 degree. First condition, comma, MR. Next condition, MR perpendicular to LN. Therefore, by geometric mean corollary, geometric mean corollary. Don't write down GMC, children. What can I say? MR square. MR square is equals to LR into RN. LR into Rn. I think so. By this time, there are many who has guessed the answer. Sir, now what are you going to do? You are going to hide the above triangle, and you will say focus on the lower right angle triangle. Earlier, I focused on the above right angle triangle by hiding this one. Now I hide this one. I'll ask you to. Don't you think so? Same stuff. Also, no change whatsoever. In triangle, which triangle? LKN. Again, measure angle LKN is how much? 90 degree. Moreover, KR is perpendicular to LN. So by geometric mean corollary, what children? What shall I say? It is RK square is equals to LR into RN. Is RK square is LR into RN. Equation 2. What do I see from 1 and 2? RHS is the same. So from 1 and 2, RHS is the same. Shall I say LHS is the same? MR square is equals to RK square. Taking square roots. MR is equals to RK. Taking square roots. If MR is equals to RK, what shall I say? R is a midpoint. That's the final line. That's the final line. MR is equal to RK. So what we infer? Therefore, point R is the midpoint of MK. Point R. MR, RK. R is the midpoint of MK. That's what we wanted to prove. That's what we wanted to prove. MR, R is a midpoint of MK. MR is a midpoint of MK, sorry, R is a midpoint of MK. Right? That's it.